All right. Hello, class. I'm here with Hazel. And we're going to see if she can howl. Here, so let's see if she can howl. Howl! 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 Good girl. Good girl. Good girl. No! No more? No more? Okay, you go down. All right. Wow, that went better than I expected. Okay. Now I have to. Oh, thank you. Someone says time for ohm puns. I forgot that we're doing ohm puns today. So you might remember that the symbol for resistance, the units of resistance, are represented by the Greek letter omega, which stands for ohms. So I have a couple of it looks like I'm supposed to say good morning, class. Actually, good afternoon, class. All right, so a couple of ohm puns. All right, let's see. So maybe I'll do this one. So there's an ohm, and this ohm costs $0. Okay. So this is ohm free. You like it? Ohm free. I hope you like it. It's hard to tell if it's funny without feedback from you guys. Here's another one. Got a bunch of ohms all in a cluster here. These ohms are not social distancing. And then there's one ohm that's all by itself. So this is, wait for it, ohm alone. Okay? Ohm alone. Let's see. Okay, some people say they're laughing. That's good. All right. And let's do a couple more. We could do, there's an ohm. And it has wheels. Okay. And it's moving. So that is mobile ohm. It's a mobile ohm. Well, Ethan wants to know how he leaves. I think you just X out the browser. I'll do two more. This one's a little bit tough. So this is like a stove top. Okay, so we got a stove top, and then we've got an omega on top of it. Okay, so this one is probably the hardest one to guess, and because I'll give you a hint, a stove top is sometimes called a range. So this is Ohm on the Range, like the song. Home on the Range. Maybe you've heard it before. If you haven't heard it, it's a great song, so you should check it out. This is Ohm on the Range. And then I'll do one more. I bet you guys can guess this before I'm done. Before I'm done drawing it, even. Okay. Gonna let you. I bet you can guess that this is Homer Simpson. All right. I'm guessing that many of you guessed that before I was even done drawing. All right. Oh, I'm seeing lots of good puns on the live stream. Okay. Well, that concludes the comedy portion of the lesson, and now we're going to go to physics. So I'm going to remind you the two concepts that we learned about yesterday. And so the first concept we learned about was electric potential difference. Which is also known as voltage. Mom, stop texting me that you're watching. Okay, so as I said yesterday, potential difference is caused by either a battery or a power outlet or something like that. So I'm going to show you the circuit symbol for a battery. Okay? So a battery has a circuit symbol that is a long line and a short line and a long line and a short line, like that. And the long line is the positive terminal of the battery. Okay? So typically speaking, we would write the voltage of the battery next to it. So maybe this is a 1.5 volt battery. Okay? All right. And we also talked about current, which is denoted by I. Okay. So I think I might have lost connection here. Current is caused by the battery. So it actually turns out that current will flow out of the positive terminal of the battery. Okay, so and then it'll go through the circuit and it'll come back around and it'll go into the negative terminal of the battery. So batteries are, they push current out the positive terminal and they take current into the negative terminal. All right. the resistance was defined as potential difference divided by current. And for many devices in a circuit, this ratio is actually constant. So this is sometimes a constant. Okay. And so when it is a constant, the device that has a constant resistance is called a resistor. Okay? It's called a resistor. And the circuit symbol for a resistor is like a jagged line. Okay? A jagged line represents a resistor. And so usually we would write how many ohms that resistor is. So maybe we'd say this is a 5 ohm resistor, and we'd write that next to it. The symbol for a wire is just a line. So the resistance of a wire is not zero. It does resist current flow a little bit, but usually that is negligible compared to the resistance of other things in the circuit. Okay, so we just ignore the resistance of a wire. Okay. So we can sort of put this together to build the basic circuit. Okay. So the basic circuit is just a battery and a resistor. So maybe it's a 12-volt battery and a 2 ohm resistor. Oh, I have a really good question. Garrett is asking, what is a real-world scenario where a resistor is needed? So resistors are put in circuits to control the amount of current. So a lot of times